All right. So my name is Brooke Delgoff, and I'm here from Sanford Health, and we support the Marshfield Clinic Research Institute. And today I'm here to talk about uploading to AWS Redshift from SAS 9 with S3. And because I'm from a health system, I do want to just start off by saying that none of the data that you see in this presentation is real data. It's all been created only for the purpose of this presentation. And if you get to the end of my presentation and you like the code that's in it, all of my materials are available using a REDCap survey at this QR code, and you will see this on the slides throughout my presentation as well. Let's take a look at the outline for the presentation. First, we'll start out with some background. We will dial back on some core concepts, and then I will talk through a macro that I've developed to achieve an upload, and then we'll do some speed testing to see which method outruns them. So as I said, let's start with some background. So if you're not familiar with either of these terms, here are some good links to documentation. But in short, these are both Amazon solutions to data storage and query. And why are they needed? Let's start with a visual. Anytime you have data or plan to have data, you need a data storage solution. And understanding how these solutions move data is essential to understanding how to optimize the process and runtimes for code doing this. In front of us, we see the movement covered in this presentation, movement of data up to the cloud via two means, with one using S3 in the middle and one without, and download with only S3. We'll be using sashelp.cars and turning this into an AWS table called delgoff_b_sashelpcars to demo the code. So let's take a closer look at the steps along these paths. The most familiar way to access, copy, or move data is the libname statement. If you spend any time programming in SAS, you're pretty familiar with the libname statement. To connect to the AWS environment, you would use a libname statement like this one. Note that I'm using macro variables to populate sensitive information, and have a couple places I've obscured the true values that you would use to connect to a real database. Once you create the libname statement, you can create a copy of the sashelp.cars data on your AWS server very easily using a data step like this one and using its libname reference, in this case AWSDB, as a prefix. By default, the conversation between local and cloud happens one row at a time, just as SAS processes row by row. But if you want to change that, you can use the libname statement options such as dbcommit and insert buff. These control how often a record is committed and how often it's inserted. In this way, processing changes to greater number of rows at a time can get your data up to the database faster. This works well for smaller data sets like the sashelp cars, and you can mess around with these options for larger data sets. But when the data gets really large or when the number of rows varies widely, you might consider taking another path. Reminding ourselves of the initial diagram, we've completed the short and easy path of the libname statement. So now let's look at the S3 buckets and how to use them for bulk loading. For awareness, there are libname options that start with BL, also telling SAS to use the S3 buckets, but I'm going to walk through the manual connection since I couldn't get these options to do exactly what I wanted. So let's start with the permissions and a connection to S3. To be able to move files through the S3 buckets, you first need to know where the buckets are, and know your credentials. I'm not going to cover the acquisition, configuration, or types of accounts we don't use, but this link to the AWS documentation can help you get started if you don't know what your setup is. Here we use macro variables to pull and store this information between runs so that credentials are not exposed to readers of logs or programs. But the connection is actually occurring in this last statement. Depending on the type of user and method of connection, you may have to take action in a web browser or use MFA during this process. A macro like this one can be placed in your autoexec file so that the login doesn't interrupt the process of the program or running in batch without supervision. As this process only needs to be completed once every 12 hours, you can successfully do this one time and then continue on throughout your day without any worries. Once you make this connection, you can also focus your attention on what data you are moving. Depending on the type of user and method of connection, you can take action in a web browser or use multi-factor authentication during this process. A macro like this one can be placed in an autoexec file so that the login doesn't interrupt your process and doesn't require a manual intervention. As this process only needs to be completed every 12 hours, we can do that once and then not again. One reason that you might take your own path through the S3 buckets is to have more control over the attributes of the data at each point. In this code, you'll see that I'm designating the AWS type based on attributes of the data in a very strategic manner that even accommodates what to do with fields using user-defined formats. I'm also creating a feedback loop that will error this process out in an unexpected or undefined data type scenario. The next step is to create a CSV file from the data. Once you know how your data will look in SAS, you may think it's good to go to AWS, but in the midst of getting to AWS, a secret CSV is created, and it might totally mess up your plans. This is a downside of the do-it-yourself method, but technically it's not novel to the process, as the bulk load options do this too. In our case, we do not need a lot of things that put a spanner in the upload, so we remove them before the CSV creation. While not shown on the slide, we also take care to make sure that all naming for variables, tables, and files are compliant with both SAS and AWS, or at least agreed upon. Next, we can copy this file through the S3 bucket into Redshift. The code here has a lot of macro variables that resolve to control and authorize the movement of data. First, we're designating the location and the name of the CSV we created, and then using a system command to tell SAS to copy it to a designated S3 bucket and retain the same naming. We use our profile credentials to authorize that conversation. Next, we'll connect to Redshift using the library reference we previously set up using libname references and utilizing pass-through SQL syntax to run this natively on Redshift. A copy statement will insert the rows from the CSV located in the S3 bucket to the table we created on the Redshift server. We use our IAM role to authorize that conversation. We are also setting some guidelines and auto-format dates, accept invalid characters as a space, rounding decimal places, and asking it to round to a maximum of 10 errors before complaining. Now that the copy is complete, we can check for errors. One thing that SAS users are used to is a good feedback from the log. So you might be a little surprised with some disappointment when you see what it says during these interactions. Here are a few examples of those messages and what to do if you see them. In the case of the second message, you're referring to STL load errors table for more information. But where is that? It's actually a table on your Redshift environment that is automatically being created and potentially something you didn't know was even there. This picture is taken from the link to the AWS website and shows an example of that table's contents. You can see that information in a variety of ways. We use DB Visualizer, but there are other methods. But you can also use SAS. The code here connects to the Redshift environment and pulls data from that table into a SAS dataset. By default, this table contains a row for each record that errored during the load. It's especially important to check this since some records could still have been loaded and each record could have had different or multiple load issues. This query also uses a halving clause to limit the returned records to only the most recent query and only the most recent runtime. Otherwise, this would pull back records for other queries too that were previously executed. It's not foolproof if multiple queries were ran at the same time or if you have access to more than just your own queries, but it works about 99% of the time. Once you confirm the table was placed on Redshift without error, the only thing left to do is clean up. Along the way, this process created a lot of SAS datasets and CSV files that are no longer needed. In order to keep your session and storage locations clean, we will use these system commands and proc datasets to get rid of them. The RM function will delete things on AWS, the del on the file directory, and proc datasets within SAS. Note the use of the colon at the end of temp table structure in the list of SAS datasets. This will delete any SAS datasets that start with that prefix. Now, I've seen a lot of code, and I've gone through these concepts, and modification of that code will be needed, but all that code has been taken from a macro I've developed called Dynamic Create Table Redshift. And that macro is available here at the QR code. So here is an example of the macro call that would be seen in code after using an include statement to read in a program containing my code with your database edits. For those of you more familiar with the idea of packages, this operates similarly by using macro parameters that you set the values of. Those things determine which parts of the code run, provide values expected to change between those runs, and control how something is done. The first two parameters are required and designate the names of the SAS dataset and Redshift table being created. All other parameters are optional, and in that default values are available, but they control code related to the CSV creation and cleaning performed within and outside the data. So if you'd like a little bit more control over those are provided. The definition program for this macro currently has 569 lines of code, which typically replaces about 1 to 3 lines of code when written using the library reference in a basic data step. So depending on how you format your code, this way or that way, it's going to have written more lines of code, so why would you ever want to do that? Well, here are some of the issues and resolutions that are addressed in the macro or its options. This and the next few slides can be used to understand why parts of the dynamic create table Redshift definition exist and help you determine if this code meets your needs. The last column can be used like search terms in the code or help guide you to the parts of the code that do this. I'm not typically a fan of reading slides to my audience, but these are pretty text heavy. And so I'll pause a little bit for skimming of the bolded words, but remember this presentation is available for you to go back to and read in more detail later. I do also want to remind you that these will be featured again in several ways, including in future presentations to be held at this year's Midwest SAS Users Group Conference in Madison, Wisconsin. So if any of these bold terms are speaking to you, please go and have a look. I will also mention that several of these issues are self-created by this very process before being resolved by it. And most of those pertain to the dependency on a CSV file needed as the intermediary. If you didn't read fast enough, or you want to see all the issues, needs, and solutions in this code base from the last 3 slides, you were probably multitasking. It's the end of the day. It's 5 p.m. We're thinking about where we're going next. You completely glazed over. That's all right. What I want to draw your attention, though, is this last one. Because of all the problems and solutions here, it's the most important. I tried using the library reference method, and it ran for more time than I have patience for. I was not interested in writing more lines of code, and I did not have time to review the input data myself. So I guess raise of hands. Let's explore that a little more. So let's take a look at the numbers. I'm going to show you a comparison of methods covered under different circumstances with actual numbers to show you where each of these does or does not excel. To do that, I'm using some fake data created by the distributed code that's freely available in the QR code and the SAS help library. Here are the attributes of those data sets. The first one we're all likely familiar with, SAS help cars. It contains information about vehicles, including things like make, model, and MSRP. It's a small data set of about 428 observations with 15 variables. The second one is one I created to be a bit bigger. It contains some unfriendly characters, in this case the plus or minus symbol and a line break, fields with varying number of decimal places, and a currency format. And the last was meant to demonstrate scenarios that fly in SAS, but that crash in Excel or Redshift. So let's take a look at some numbers. All right, so right off the bat, we see that the macro is not always the best solution. In row 1, we see that it takes 16 seconds to upload the Dinky SAS help cars dataset using the macro, but only seconds using the LibName options. This is because of all the extra steps being taken in those 569 lines of code. It simply cannot outrun the one data step even without the bulk load options. SAS goes through those 428 observations one by one or 1,000 at a time faster than it can execute 569 lines of code on the same data. If that makes sense, right? This quickly goes out the door when the size of the data increases dramatically. The base LibName now taking over 20 minutes. Even with the additional options, the data step still lacks performance. But strikingly enough, the macro now throws an error when using only the required arguments. And when we look for more information on that STL load errors, we find that line breaks are causing a line feed error. So when we created the CSV in the middle, we tried pushing its contents into the AWS table, but it accidentally sees coffee break as a value of row number, which is not allowed because that field is numeric. Once we use the free text equal yes option, we see the dramatic difference. In the last row, you saw that the macro with default settings was the winner. But what you didn't see is that the field, this really big field, was longer than 16,000 bytes, which is the SAS dataset maximum. Now, 16K is less than the 65K true maximum length, and the actual length was only something of like 4 digits. So, in reality, did we see this error actually occur? No, but it'll be of concern between 16,000 and 32,000 where it actually would cause truncation. And that's because UTF-8 encoding actually uses up to 4 bytes for each character. So like the issue with truncation, there are definitely opportunities for loss of data when we're changing or eliminating that data as well. And so the assumptions we're making of not needing the line feeds or carriage returns in our data. Those things aren't meaningful in our data, so we're taking them out of there, but that may not work for everybody. So with that, I will wrap things up with some links to documentation. Since most of the code is dependent on your particular environment, I will also start with the source documentation links, of which there are many. In addition to these source system references, there are also several posts, papers, and previous presentations to consider. And that's the end. So I want to take a moment to give out some very necessary thank yous. Today's code would not exist without Stephanie Rausch, data engineer team lead, and special thank you to her for being the brains behind the operation and trusting me to macrotize her code and share her work today. I also want to thank Dr. Heather Rhodes and the Goldbach family for financially supporting us both during these work hours and at this conference today. With that, I will take any questions. Yeah. So for the most part, it works in like 97% of the cases we use it in without having to do any of the additional free text parsing, because it really only malfunctions when you're doing like fields that are containing an entire document's worth of text and have a whole bunch of like, you know, sometimes if there's like Spanish words or there's special characters or things like that, where when it exports to that CSV, it tends to break. But otherwise, it works pretty well. Yeah, so I'll go back to that. Yeah. So in this one, there's a particular concern between 16,000 and 32,000 length size, because SAS would say, okay, it's good to go, and then it would get to AWS, and AWS would just truncate it. And it wouldn't even tell you that it's done that. Right. Thank you. And a couple weeks ago, I was selected as the conference chair for the Midwest, and so being that we just finalized things 3 weeks ago, there are a lot of things that are still in the works, and so if you have any ideas on things you'd like to see at a conference, or if you're in the Midwest area or willing to travel to Wisconsin in November, I encourage you to reach out.